Almost anyone can thoughtlessly tear an engine apart. However, only a well-trained technician knows how to methodically disassemble an engine while gathering information on what must be done to rebuild the engine correctly. Proper disassembly techniques will prevent part damage, will allow for essential part inspection, will result in component organization, and will save time during engine reassembly. This video will demonstrate the most important tasks for disassembling any make or model of engine. The use of special tools is stressed to help save time and to result in a superior engine rebuild. You will learn fundamental service procedures and tricks of the trade so you can professionally rebuild any make or model engine. These part failures resulted from mistakes made during engine rebuilding. During engine repair, small mistakes can often result in serious part damage. How would you like to explain this hold block to a customer after you've worked on their engine? The customer would not be very happy with you or your work. Engine technology is changing very rapidly. A good rule: try to learn something new every day that will improve your skills. Then you will become a better automotive technician every day. Engine teardown is simplified if you take a couple of minutes to mount the engine on an engine stand. If you're using a lift chain, make sure the bolts are large enough in diameter and that they thread into the part at least 1 1/2 times their diameter. Snug the bolt down completely. To avoid bolt breakage and engine damage, lift bolts must not stick out, but should clamp tightly on the lift chain. Fasten the chain to opposite corners of the engine so the engine is lifted level. If needed, form an eye in the chain with a bolt and a nut to keep the crane hook and engine from slipping. It is dangerous to place a lift hook around a chain not formed into an eye. Mount the engine stand arms onto the cylinder block. Again, make sure your bolts thread in 1 1/2 times their diameter so that they won't break off. If you ever drop an engine, you might get lucky and only lose money replacing parts, but you could also lose toes or a foot. Raise the engine slowly while keeping all parts of your body out from under the heavy engine. With the engine in the air and level with the engine stand, slide the engine stand together and secure it with bolts. With the engine secured on the stand, you are ready to begin engine disassembly. Most crankshaft harmonic balancers are held in place with a large bolt and are press fit. Use an impact wrench to remove the large bolt. Never pry on the outside diameter of a balancer or it will be ruined. Instead, bolt a wheel puller onto the balancer so that the puller contacts the center of the crankshaft snout. While wearing safety glasses, use an impact wrench to force the pulley off the crankshaft. If a bolt breaks, it can shoot out with blinding force. With the damper off, you can start removing other front-end parts. Use common sense on deciding which part to remove next. If you have a timing belt, remove its cover while keeping the bolts organized. Relax belt tension by loosening the tension adjuster. A used timing belt is normally replaced whenever it is removed from the engine for service. It is relatively inexpensive, but it is critical to engine service life. Remember, if a timing belt fails, serious valve and piston damage can result. Parts with a gasket may require light prying or a rap with a mallet to free them from the engine. Use a soft face or dead blow hammer to prevent part damage. Timing sprockets are usually secured with a bolt, but they can also be pressed fit. If held with a bolt, light prying will usually free them. Sometimes they will slip off easily by hand. Here, the mechanic is removing the backing plate. If a sprocket sticks to its shaft, use a wheel puller to remove it. Do not hammer on a timing sprocket. When prying off engine covers, be careful not to gouge or nick gasket sealing surfaces. Drive a heavy shanked gasket scraper between the parts and pry lightly to avoid part damage. Here is a badly worn timing chain. After removing the cam sprocket bolts, pry lightly to remove the sprocket from the camshaft. If the oil pump mounts on the front of the engine, remove it at this time. To begin, remove all external parts. Remove the intake manifold. Taps from a mallet will usually free the gasket material. Also remove the exhaust manifolds. When removing the valve cover, be careful not to dent or warp the gasket sealing surface. Next, remove parts over the head bolts. Make sure the cam journal caps are numbered so they can be installed in their original locations on the head. Also make sure the cams are labeled intake and exhaust. If you're working on an overhead cam engine, remove the camshafts. Next, remove the head bolts. Once all the head bolts are removed, pry lightly to free the head gasket from the block. Sometimes the head gasket will stick, and you must lift one end of the head to tear the gasket free so the head can be removed. Scrape gasket material from the block and the head. If the head or block is aluminum, be careful not to nick or gouge the soft aluminum, or you could cause a head gasket leak. With a push rod engine, you can sometimes remove the head with the rocker arms and push rods in place. Remember to always keep parts organized. They can be select fit, and they should be reinstalled in their original locations. Part organization will also help problem diagnosis during part inspection. Place the push rods in an organizing tray like this one. Next, you might remove the lifters. Here's a lifter removal tool. When you push down on the knob, the end of the tool expands and locks onto the lifter, so that they can be slid out of the engine. Sometimes lifters will stick in the lifter bore. This is due to a buildup of oil film on the lifters. Jerk back and forth on the lifter to free it from the cylinder block. If the lifters are going to be reused on the camshaft, they must be kept in order so that they can be reinstalled on the same lobe. A bolt installed in the front of the camshaft will help with in-block camshaft removal. As you remove the cam, rotate it and slide it out slowly. You don't want to nick and mar any of the cam lobes during removal. If the cam might be reusable, place it somewhere where it cannot be damaged. To begin bottom-end disassembly, rotate the engine on its engine stand. This will give you access to the oil pan and connecting rods. Remember to tighten the bolts on the engine stand so that the engine cannot flip over. Remove all of the oil pan bolts. Force a wide, thin blade tool under the pan flange and pry up lightly. Try to avoid bending the flange because it will have to be straightened upon engine reassembly. Inspect inside the oil pan for debris. Particles in the oil pan indicate engine problems. A bit of aluminum might be from a broken piston skirt, for example. Unbolt and remove the oil pump if in the pan. Then check the connecting rods for markings. Each rod should have a number on the cap and on the rod body. If numbers are missing from the rods, you must number them. This will let you keep the caps and rods in order. If a connecting rod number is missing, use a number set to stamp the same number into the rod and into the cap. If a rod cap is installed on the wrong rod, the rod bore will no longer be round, and serious bearing clearance problems will result. You should also make sure there are numbers and front arrows on the block main caps. They, too, must be installed exactly as removed to keep the main bore in alignment. Mark them if needed. Before piston removal, use your fingernail to feel for a ring ridge at the top of the cylinder. You must remove any ring ridge to prevent piston damage. If you try to drive the piston out over the ridge, the rings will catch and damage the piston's ring lands. Use a ridge reaming tool to cut any lip out of the cylinder. Mount the ridge reamer into the cylinder, then adjust it outward until it is snug against the cylinder wall. Do not over-tighten the tool, or it will not turn freely. Mount a ratchet on the larger drive nut of the ridge reamer. Slowly turn the tool while watching how much metal is being removed. You only want to cut the lip flush with the worn cylinder wall. Readjust the cutter after about 2 or 3 revolutions. Occasionally, feel the lip to make sure you're not cutting too deep. Once the lip is cut flush, remove the tool and go to the next cylinder. Here you can see where the lip has been cut almost flush with the cylinder wall. Use compressed air to blow shavings off the top of the pistons and out of the cylinders. These shavings could scar the piston and cylinder during piston removal. Unscrew the nuts or bolts on one connecting rod. Then pop off the rod cap. This will let you remove the piston rod assembly from the block. Use a plastic or wood hammer handle to push on the bottom of the connecting rod. Slowly force the piston and rod out of the block. Use one hand to grab the piston to prevent it from dropping out of the engine and onto the shop floor. Repeat this operation on the other piston rod assemblies. Again, be careful not to let the piston fall and become damaged striking the shop floor. Install each rod cap and nuts back onto the correct rod body. Place the rod nuts on the same rod bolts with the shiny or same side down. Place the piston rod assembly into an organizing tray or in sequence on your workbench. If you have a one-piece rear main seal, remove it now. Unscrew the main cap bolts. Again, make sure the main caps are numbered. Tap lightly on the cap to free it from the block. Then, use the bolts to lift the caps upwards. Carefully lift the heavy crank out of the block and place it where it cannot be damaged. If it's a two-piece, pop out the old rear oil seal. A screwdriver under one end will usually free it. Use your finger to pry out and remove the main bearing inserts. If working on a high-mileage engine, remove the block core or freeze plugs. Drive a pry bar through the plug with light blows. If the plug falls down into the engine, use needle nose pliers to retrieve and remove it. Ideally, the plug will puncture or spin and not fall inside the block. This will let you pry the core plug out of the block more quickly. Be careful not to damage the block sealing surface. If you mount the piston rod assembly in a vise, use soft lead or plastic vise caps. Vise caps will prevent marring and damage of the rod I-beams. Carefully mount the connecting rod in the vise and lightly snug it down. Remove the old piston rings. Here, the technician is using the ring expander tool. Normally, start at the top ring and work your way down. You can also spiral the old rings off by hand. Use your fingernail to grab the ring and twist it and pull it around the piston. You need not be as concerned about breaking the old rings as you are when installing the new ones. Also, lift off the expander spacer from the oil ring groove. Here is a piston ring groove cleaner. It must be utilized on used but good pistons to remove carbon from inside the piston grooves. It has several cutter widths to match the ring groove width. To use this tool, insert the correct size cutter into the piston ring groove. Then, tighten the tool down around the piston. Slowly rotate the tool around the piston while watching inside the piston ring groove. Only cut out the hard carbon until the inside of the groove is shiny. Do not cut too deep, or the piston could be ruined. As you can see, we have only cut the carbon from the inside of the groove until the surface is shiny. If you cut too deep, it can weaken the piston and cause it to fail in service. Repeat this operation on the other ring grooves. If the carbon is not removed, the new rings could be jammed against the cylinder walls, causing the rings to freeze against the cylinder during engine operation and break-in. Use a dull scraper to remove carbon from the top of the pistons. You could also abrasive blast the piston heads. Try to get as much of the carbon off the pistons without marring and scratching the head surface. Blow metal shavings off the pistons and inspect them for damage. If you have floating piston pins, use snap ring pliers to remove the lock rings. Wear safety glasses and insert the plier tips into the snap ring. Squeeze on the pliers to compress the snap ring and free them from their groove. Repeat this on the other snap rings. Use a driver and light hammer blows to push the piston pin out of the piston. If you have a press-fit piston pin, you'll need to use a hydraulic press and special driving tool. Never try to use a hammer to remove a press-fit pin. Always clean all engine parts thoroughly. Scrape all old gasket material and wash off dirty oil in a cold solvent tank. Remember, if you leave even one bit of old gasket material, it can lead to serious oil or coolant leaks. In auto mechanics, cleanliness cannot be overstressed. Even one speck of metal left inside an engine could freeze an oil pump or score a cylinder wall and cause serious engine damage. Wash both the inside and outside of parts thoroughly. A good mechanic will spend almost as much time cleaning parts as on any other operation. As you wash parts, inspect them for signs of trouble. You might inspect a piston for cracked skirts, damage to the piston head, damage to the ring lands, and other problems. Do the same as you wash the connecting rods. Look for marks on the I-beam. Look at the inside of the bearing bore for signs of rod bearing movement. Inspect the rod's small end for signs of bushing wear. Wash off all of the piston pins. If the pins look good, mic them to check wear. If they show definite wear patterns, replace them. As you clean the rocker arms, inspect their wear points. Check the tips for signs of wear, and also check inside the rocker arms. Also, clean off the lifters while inspecting them. Never soak lifters in solvent. This could allow them to fill with solvent. Clean the outside of the push rods. If they are hollow, run a piece of mechanic's wire down through them. This will help force out any debris that has become lodged inside the push rod passage. If installed in an engine, a clogged push rod could lead to rapid rocker arm wear, because it would starve the rocker arm for oil. Use compressed air to blow all parts dry, to ready them for further inspection and measurement. Wear eye protection and blow away from your body. To inspect a rod, look inside the rod big bore for any signs of bearing movement. Abrasive marks inside the rod bore may require rebuilding or replacement. Inspect the rod I-beam. Any marks like this would require rod replacement. Also, inspect the rod's small end for signs of wear. Check the back of the rod bearings for size markings. The letters STD mean the crankshaft and bearings are standard size. .010, .020, and larger numbers mean the engine has oversize bearings and that the crankshaft journals have already been machined undersize. This connecting rod bearing shows signs of normal wear. Any rod bearing damage would normally cause connecting rod damage. This is just one reason why it is desirable to keep all parts organized together. This is a badly hammered rod bearing, indicating the need for connecting rod replacement. This piston has been hitting the bottom of the cylinder head. This would tell you that the crankshaft, connecting rod, and rod bearing are also badly damaged. Proper piston skirt inspection is often overlooked. A piston skirt can wear or crack easily. If you overlook a cracked skirt, the piston could quickly fail in service and cause severe damage to the cylinder block, connecting rod, and other internal parts. Here's a burned piston. The ring gland was actually melted and blown away. The top of the piston is also holed, causing the engine exhaust to pump out tremendous amounts of oil and blue smoke. Piston clearances are normally given in 10,000ths of an inch. This makes even minute wear critical. This first pin would have to be mic'd. However, you would know from inspection that this second pin has to be replaced. Check the rocker arms closely for wear. Inspect at the point of contact the push rod ends and valve stem tips. Also make sure none of the push rods are bent. These aluminum rocker pivots are very high wear points and normally require replacement. If worn and not replaced, valve train clatter can result upon engine reassembly and operation. The bottoms of new lifters are actually crowned or humped. Worn lifters like these will become concaved or dished. This would often mean that both the lifters and the camshaft should be replaced as a set. Lifter wear normally means equal or more cam lobe wear. This badly worn lifter would instantly tell you to order a new set of lifters and a camshaft. If the engine is low mileage, you may be able to reuse many of the major engine parts: cam, lifters, crankshaft. Measure camshaft wear to see if the cam can be reinstalled in the rebuilt engine. Also, inspect and measure the crankshaft. If you find major wear or damage, there's no need to take the time to mic the journals. Simply send the crank out to be machined. In closing, remember that every step of an engine rebuild is important to engine life. If you overlook even one step, you could end up like this cylinder block, out of service and out of a job.